Hello everybody. I wanted to finish up the video I started last night about PPP and how to set it up and stuff like that. It's actually really easy to configure in regards to setting the encapsulation on the interfaces and stuff like that. But what I wanted to go over really quick was authentication. Authentication in its most basic concept is simply saying I am router 1, this is my IP address, which I will bring up, where is it? Right here. This is my IP address, okay, 10.1.1.1.1, and if I do a show interface, serial 0000, you can see that its encapsulation is PPP, okay. And what you'll see here really quick is LCP is link control protocol. This right here is your layer 2 connection. And, no, I'm sorry, that is layer 1. Layer 1 is your link control that once it detects signaling on the interface, it says, okay, I sense the other guy, and then what ends up happening at that point is IPCP kicks in, which allows you to do layer 3 connectivity, and CDPCP. What does that do? Well, let's find out. Show CDP neighbors. Well, guess what? R2. I have R2 on my serial 00 interface. CDPCP is Cisco Discovery Protocol Control Protocol. All of your control protocols in PPP are going to have IPCP, CDPCP. I know it sounds like a lot of just jargon, but that's exactly what it is. So, there's no way for me to delegate the size of the packets, but like this is a 64K link, right? Where'd it go? Bandwidth 128K. I'm sorry, it's a 128K link. Um, so that basically means that it's a 128 kilobit link, which would be the effectiveness of one ISDN connection. So, but what this does, in a nutshell, is it allows you to say, when you're trying to connect everything up together over here, that this guy he can back up who he says he is. So this guy says I'm encapsulated PPP on the 10.1 network. This guy over here is encapsulated PPP on this guy on this interface. He is also 10.1 the 10.1 network. So they're able to authenticate to each other. This makes sure that no one else is able to get on the link and say I am somebody else. Like I said in the previous video, that authentication is different than encryption. Authentication says you are who you say you are, and encryption means you can't see what I'm sending. So those are the two main differences. Don't confuse authentication with encryption. Same thing with when you're going into your email. It is a secure site, so it's actually authentication and encryption all in one. So when you see the HTTPS, it's a different port. 443 is HTTPS or SSL. What that does is it allows you to go to a server, like if you use Yahoo or Gmail or whatever the case may be, you'll see up in the web browser it'll say HTTPS, and usually you'll see like a little key or some sort of information that states that it's secure, that you're authenticating to a secure server that you are who you say you are, and then all of your email and stuff like that is encrypted. You can't see what's going on. Not to say that you can't see it. What's the best way to put it? You have to watch your web browser to see if anything changes, because you might authenticate HTTPS, but it might flip you back to just regular HTTP, which means you're flipped from one port to another on the firewall. That's all that really means. But I've authenticated, as you can see. Sorry, I was show run. Now I've authenticated right here. I've got oh, wait a minute. No, I didn't. I lied. This is router 1, right? Yes, it is. So what I'm going to do is I have to put PAP in there, which is Password Authentication Protocol, which unfortunately is clear text. CHAP is encrypted. So we're going to go interface serial 01, and we're going to go PPP authentication is PAP. Now what'll end up happening is the link will go down and then come back up. So we'll do the same thing with this guy. We'll do a config t interface config t interface 00000. We're going to type in PPP authentication PAP. Brings it down. So then at this point, what ends up happening is anything that you have an adjacency with in what do you call it? Your routing protocol. In this case, I'm using OSPF as indicated in the lab. You need to run OSPF. So I should be able to do ping 10.1.1.2, and I can't, which means I have a connection between the two point-to-point connections, and I'm authenticating. So everything, it's anybody else that tries to pull this connection out and plug something else into it, it's not going to come up unless they're authenticating on their end. So if you pull this guy out and you plug, say, this guy into this port, if this guy can't authenticate with a username and password up here, then it's not going to work. It's just not going to come up. It's going to be line up, protocol down. That's all. This lab is pretty much done. Now you can do a debug and do PPP authentication, and but that's only going to work if, well, actually, this is router 1, which is this guy right here. So let's try to do this real quick, and we're going to pull up router 0. Actually, let me do that. Let me do this real quick. Okay, there they are. I just want you guys to see how this works in a conceptual manner. Is there a way to squeeze this in? Oh, sweet, check that out. So this is debug is on. So what I'm going to do is, I'm under the interface, so I'm going to do a shut. Okay? Now, I'm going to do a no shut. Watch this screen right here. Okay? And notice how there was some things and it says change to up, authentication required, authenticating peer, phases and forwarding, attempting forward, and then it shows that it's up, and then it just came up a second ago. So that right there tells you that authentication is working. Now you can do a debug UAll, and then you type in debug PPP packet. Yeah, that's what I thought. The iOS can be sticky sometimes. Debut debug PPP packet. So I'm going to do the same thing. I'm going to do a shut, and I'm going to do a no shut. And it would help if I could type in, right? There it goes, and there it's that's how it comes up. I mean, there's not going to be any real major things going on, but now it's sending information across. Now, what it did at the first part here was it says, actually now it's jumping all over the place for me. This is what happens when you turn a debug on. This is remember the keep alive is every 10 seconds. So every 10 seconds it's going to start sending information to make sure the link is up. So I'm going to type in UAll and turn debugging off. That's how you debug, that's how you confirm you've got authentication going across all your links, so on and so forth. There's not really too much more to it than that. PPP is pretty straightforward. I know I struggled with it a little bit last night trying to get it up. That's because I didn't set it up quite right the first time. And I watched a video a little while ago and read a little bit up on PPP, and I was like, oh, that's what I'm missing, because you have to set it up, like I said last night. Full IP reachability is the first thing you want to achieve. You don't want to throw any services, any NAT, any security, any authentication, any encryption, any redundancy in there until you have full IP reachability. As soon as you can, what do I mean by redundancy? Let's say, for instance, okay, let's say that I had everything was going this way. Okay, if any traffic from this direction comes in, what'll end up happening is both of these links are the same. At least they should be. Router 0. So and show interface serial 000. I see bandwidth is, oh, it's T1 line, huh? Yeah, 1544 is T1. It's a T1 speed. And then what is show interface serial 00001? This one is T1 as well. Okay, they're coming out T1. So what'll end up happening is both of these guys will they will load balance accordingly. Let's assume that this is like I said, inbound traffic, and you're sending. They're both the same network. Let's say this is both the same network, and you have two points of connection coming in. Like you have it's the same network as a whole, and they're both routing outbound. Okay, what'll end up happening is any traffic coming from here inbound, it'll load balance equally across them. What'll end up happening is with what I would do if you wanted to specify which route you want to take the most of. Let's say they're both a 10-1 network. Okay. What you're going to end up doing is, because this one will have a connection to here, this guy will have a connection to this one, this guy will have a connection to here, it's fully redundant. So what will end up happening is, as traffic comes in here, you could specify a static route coming in and saying anything destined for the 10-1 network will go out this interface, and then you'll put a weight on it. Static routes by default are a metric of 1, and you can go in there and specify a metric of 2 on one of them. As long as it sees a metric of 1 is a better route than a metric of 2, it'll always pull that route. A floating static route is actually really good if you want redundancy in your network in the regards to what's the best way to put it? If you want failover that you don't want in your routing table. So what'll end up happening is I'll do a config t. I'll do IP route. We're using OSPF, so we'll do show IP route. See right here, you'll see 110. This is the metric. Okay, your metric is 110, and your administrative distance is 65. That's just OSPF's. That's the cost on the link, but this is the metric. This is 110. So if I go in here and I put in a static route to either one of these locations, so let's go to the 209 network is 110. So we'll go IP route and we'll type in 209.165.200.0, 255.255.255.224. We're going to type in 109. Well, actually, I should say we'll go out the 209.165.200.226. We'll have a metric of 109. Now, if you do, notice how there is no static routes in here. Everything's either dynamic or connected. By putting in a better metric, this 109, it's one administrative distance better than, or I'm sorry, one metric better than this route right here. Okay, do show IP route. Notice how it took the other route out. Actually, let me do this. Notice how this route is in here as a static right here, and this route has been taken out. I'm sorry, this route has been taken out. That's because of the fact that this route has a better administrative distance. It installs a static route. So if I go Control A, no IP route, there. Now if I do the same thing, I do type in IP route and I give this a 111. Okay, 111. Hit enter. Right, there, and do a do show IP route. Do show. It doesn't install it into the. Well, yeah, it did. 111. But see, they're in order, so it'll go to this one first because this has a better how do I want to say it? This has got a better, it's the longest match. This one will get pulled first, then this one will get pulled. See, this iOS is being a little funny because um, typically you're going to go with the longest match that has the best metric. So um, this is the metric right here. I made it one metric better or worse than OSPF, but we're gonna take that guy out of here because I don't want to have any issues. Control A, no IP route, so that takes care of that. But that's the concept. So if this ever, with this still showing up, if this route ever went down, like OSPF went down or the routing protocol broke, it would still have a default route in there. This would be a static route. So that's how that would work. That's a floating static route. It's technically not supposed to install itself into the routing table until it 1 increment higher might do it, but in my understanding, it shouldn't do that even regardless because this has got a better administrative distance than this. Because this is 110, this is 111. So if you are ever in a bind and you want to have it set up to where, let's say for instance, the routing process ever fails, which does happen, you want to make sure that you have a backup route out of your network, even if if the connection from point A to point B is still up, which means you're still able to get traffic across, but the protocol itself failed. The router hiccuped and it's no longer using OSPF, and the process itself failed and it's no longer routing via OSPF. You still want to have a floating static route there that will kick in if OSPF drops. If OSPF drops, your floating static route will come in as a backup and be able to send the information because it's still having administrative distance. It's a little bit worse than this, but the concept is still there. So that's how floating static routes work. Floating static routes will be your best friend in a case where you might have two routes out, where you might have, let's say for instance, you've got another router right here, and this guy right here, will say, is a 10 meg connection, this guy's a 15 meg connection. What you could do is you want to have everything going out this guy, and then if this guy link fails, you have a static route that points out this guy. But that really doesn't make much of a difference unless you're trying to do some sort of performance routing, which is a CCIE topic. You won't even come close to that because there's so many things that come into PFR that you need to know about, like IPSLA, which is a way of testing the link as information is going across it, and so on and so forth. But the big deal with PFR is it does so much that it's really if you go to internetworkexpert.com, let me do something real quick. I had to pull up Internet Network Expert's website, and actually what I'll do is I'll click on this guy, and there are it's going to load the video, and I'm going to pause the video as soon as I can. What will end up happening is you go up here, I'll go back to this thing, but there are 6 videos, and it goes through basic conceptual understanding of PFR. In order to watch this video, you actually have to have an understanding of PFR, what it does and how it works, and where it's migrated from, and then where it's at now. And then as you come up through, these videos will come in handy. It's actually missing out of the videos that I have for my CCIE prep, but the idea is the same. So, but if you come back over here, you've got all these V-seminars where they talk about troubleshooting, and there's like 7 hours worth of video there. And then there's a bunch of other things where if you're having a hard time with, say, where is it? Route redistribution, if you're having a hard time understanding that. Now this is the CCIE level stuff. For the CCNA, doing basic route redistribution is a matter of taking a static route somewhere. So like if you don't want to have OSPF running, you can take this route right here and redistribute it into it to where if you don't want to advertise it out to everybody, you can, say redistribute static into OSPF, and it'll show up as a static route. But that's it's not beyond the course, but that's another video. So that's it for PPP. I hope you've enjoyed, and I'd like to thank you for viewing.